Hello, this is Ashkan from Nuop Army, and I am basically trying to show you how to design curves for considerations in this video because multiple people asked about it, and I'm going to do something a bit controversial, which it shouldn't be, but we'll show you how we did it in two of our samples in both Unity and Unreal at the same time. And of course, the knowledge of how to do this is basically something that is engine independent. So here is our cat AI for the Unity sample. And for example, the cat, some of the considerations are pretty easy, like morning sleep has a consideration which is a binary. Either it's the time between 6 a.m. and 10 a.m. and at some time between these it returns 1 and at other times it returns 0. So the curve only here and here matter. But sometimes it's really hard, like searching for mice, for example, need to know how hungry we are. Now we will normalize the hunger value between 0 and 1, and the closer to 0 we are, it means we are more hungry. And until sometimes we are really hungry, but after we go above a certain threshold, it really doesn't matter. So the curve will look like this. But at some times we need to know if we should search for mice or eat one. And we search for one if there is an influence map around us contains a mouse. So we have an influence map search, have a map name here, and we say search in our 30 meters radius for mice, and if you found a value greater than 0.8 means that you should go there because there are lots of mice around there probably. But this action shouldn't always be chosen. Sometimes we are close enough to a mouse, which again for that, hunger matters. But also the distance to that mouse of course matters because we should be close to be able to eat. So the hunger curve is almost similar, maybe a bit more, like it will be more return 1 more than the previous one because the curves, if you are close enough to a mouse, if you are not too full, let's eat it, so you will not need mouse soon enough. That's consistent with actual cat behavior as well. And we need to know when we can eat basically, and we can eat if the distance is between 0 meters and 2 meters. We can go to this eat behavior. Higher than 2 meters we cannot do this, so the distance will only return a score between 0 and 1 for distances of between 0 meters and 2 meters. And the closer to 0 it is, it's easier to eat, so we'll return 1. But when we are really close to 2 meters, it's not that easy to hunt, and the mouse should, might get away. So we'll return a score closer to 0 for those values closer to 2 meters. Now in Unreal, I am going to show you a different behavior. The behavior is when should the player move toward the kitchen and when it should eat food. And here we aren't using distance for both of the actions. The eat food action simply has a consideration which checks if there is an overlap with the kitchen. And if it is, there is an overlap, it returns 1. And if there is not, it will return 0. And the overlap function almost always returns something between either 0 or 1. So this curve, which is binary for values greater than 0.5, will return 1. So as you can see here, this will always return 1 if we are overlapping with food. And hunger is kind of similar to the previous one, but like in reverse, because when we are closer to 100, it means we are more hungry in this sample. So it's almost linear, so when we are getting more hungry, we will simply give it a higher score. But if we are not overlapping, this will not return a high score because the overlap will return 0 as a score. But go to kitchen, if we are hungry enough, as before, and if our distance to the kitchen is like far enough, we'll try to go to the kitchen. So how do we do the distance here? Here we say, okay, if our distance which is between 0 centimeters and 3000, which is like 30 meters, then it's logical to have a score for this distance. Otherwise, it will be like more than 30 meters, it will always return 0 because it's too far. Doesn't worth going there, basically. But as long as it returns something higher than 0, like between these, this action will score high. So here, because we have the overlap as a condition for eating, we don't need to care too much about how the curve for distance is created, and we will return always something like near 1. But this simply will basically score a high number when we are like between 0 and 30 meters of the object, but the other one, when we get there, will score higher than this one, and then as a result we will be eating instead of just moving toward this. And another thing that we did here is having distance parameters. Let me find the weight parameter. So the weight of this one is 0.9, so it will never return 1. At most it will return 0.9. But the weight for the eating action is set to a value higher than the moving toward kitchen action, which is 1.0. So at most the other one, which moves toward the kitchen, returns 0.9, but this one, when we get close and it returns 1, its weight is 1, so it will win the contest from the other one. We could also use priorities instead of like weights. We could use many different things to achieve the same goal, and that was mainly what I wanted to show. And the Unity sample which I'm using here is more complicated, so has more complicated curves as well. So for example, for seeking other cats, we have like 4 considerations. So this is a more complicated sample and has more complicated curves. In Unity, in Unreal, the FPS sample is like that. This live simulation one isn't that complex, so I chose to show that because basically it was similar, at least a bit, to this Unity sample, which I was showing both are live simulations. But the FPS sample in Unreal is more complicated and has more considerations with more interesting curves. And I hope that like by showing this video to you, I've shown that like it's not too hard to design curves for different situations, and it's not only about curves. You can use priorities and weights and other things in the system, other features in the system to basically decide when each action should win the contest compared to another, because usually you don't want to consider all actions like in your head, but you want to know, okay, if I have reloading and also shooting, when should I shoot, when I should reload. These two you usually care about when the first action will win and when the second one. For example, maybe when you are like not close to any enemy and have like still 3 more ammo to go, you can reload. But if you're close to other enemies and you have only 2, maybe you first shoot those 2 and then reload, or you first take cover and then reload. So you don't need to, for example, necessarily in your head compare the score of this with all other stuff. Automatically, when you create a good curve for, let's say, get health pack, then the curve will need to be made in a way that get health pack gets priority over reloading if your health is too low. But usually that's easier to do. Like if your health goes too low, that action you should go haywire and just say 1 1 1 1 1 1, and it will usually win, because you will like reload is only 1 if you do not have any ammo and you have enemies close by or you are in cover. And if you still do not get the desired effect, you can consider health when you are deciding if reloading is the best action or not. So for example, you can return a low, like have a health consideration for reload, which says if you have low health, do not give reload a high score, give it a 0.7, like make it 0.7. instead of 1. And a consideration doesn't have to return 0. It can always have like some value for 0. It can say, okay, for health more than 50%, I will return 1, and for health less than 50%, I will return 0.8. So if I'm not too healthy, reload isn't like the first action chosen, unless like a health bar is far away and I have one enemy. So you just mix and match to find the desired behavior. I hope this has been helpful. So to summarize, you need to know the limits of, for example, what values are valid for you. Like, for example, the distance here, the valid values are less than 2 meters. The other one was less than 30 meters, the unreal one. And also you need to know like what the minimum should be for a curve and what the maximum should be. It's not always 0 and 1, and then the slope, which is like the main concern of most people. But after you figure these, like the limits of the maximum value of the curve and the minimum, and the limits of the variables that are being normalized for the curve, like the health or the distance or whatever the value is, then the shape of the curve is easier to decide on because it's more obvious usually after you have those limits. But if you think that, oh, all of my considerations have to return 0 at some time or have to return 1, then that becomes hard. That shouldn't be your assumption. So a health consideration which is added to a reload or a shoot action doesn't have to make the action score 0 if you are on low health, but it can make it score like 0.2 instead. So still you might shoot, but the priority is lower. It should probably return 0 if your health is full. So that's a case that you maybe want to consider. So maybe like if your health is full, then the health consideration should return 1. That's another thing. But, or if you are, for example, shooting and you don't have ammo, okay, then the ammo count consideration will return 0 and you will not choose the shoot action at all because you cannot shoot. But in other cases that you can do an action but it might not be the best, you will return as your minimum something higher than 0 usually. And if you look at Dave Mark videos as well, he has one in JDC with another guy from Lockheed Martin, which they show the curves that they use for different behaviors. They talk about like these and different many other different things as well. I will try to link that in the description of this video as well. Enjoy making great AI.